Well, hello everyone, this is Mohammad Badruddin and today we are going to solve lab number 6 from JWT Attack module from Web Security Academy from Portugal. Before going to solve the lab, this disclaimer as always for you, this video and its contents are only for educational and awareness purpose and I do not support any unethical or illegal act. That's been said, let's see what we have today. So in previous two labs, means in lab number 4 and lab number 5, we saw how we can inject the self-signed JWT via JWK parameter and JKU parameter, right? And in both labs, lab number 4 and lab number 5 depends on asymmetric algorithms, that is RS256, which is RSA SHA256, right? So in today's lab, we are going to inject again the self-signed JWT, but this time we will use the parameter KID. So it is also possible that we can use directory traversal technique to sign the JWT, right? So servers may use several cryptographic keys for signing different kind of data, not just JWT. For this reason, the header of JWT may contain a KID, which is key ID parameter. And this parameter helps the server to identify which key to use when verifying the signature, right? So whenever server needs to verify the signature of the token, so it chooses the key from this key ID, right? So verification key are often stored as a JWK set. In this case, the server may simply look for the JWK with the same KID as the token. So however, the JWS specification does not define a concrete structure for this ID. It's just an arbitrary string for the developers choosing. For example, they might use KID parameter to point a particular entry in the database or even the name of a file. So this KID parameter, maybe the developer created a table for KID. Whenever server needs to verify the signature, server need to fetch the KID from the database, right? So it could be a database table or it could be a file, and in that case, once the server needs to see the file, that means it could be a directory traversal attack vector exist. So if the parameter is also vulnerable to directory traversal, an attacker could potentially force the server to use an arbitrary file from its file system as the verification key. If the attacker point any arbitrary file which attacker controls, and here attacker change the path, fine. So instead of looking at the genuine file, the server will look for the arbitrary file which is pointed out by the hacker in the KID value. So this is especially dangerous if the server also supports JWT signed using a symmetric algorithm. And in this case, an attacker could potentially point the KID parameter to a predictable static file, then sign to JWT using a secret that matches the content of the of this file. So you could theoretically do this with any file, but one of the simplest method is to use /dev/null, which is present in the most Linux system. So as this is an empty file, so it will fetch nothing. Nothing means null, and therefore the signing token with a base 64 encoded null byte will result a valid signature. As I mentioned before, that if the server stores its verification key in a database, the KID header parameter is also potential vector or attack vector for the SQL injection attack. So instead of giving the path to the file, we can put here the SQL query, fine. But in this lab, we will see only the directory traversal. Now this is lab number 6. We need to bypass the authentication via KID header path traversal. This lab uses a JWT based mechanism for handling session. In order to verify the signature, the server uses the KID parameter in JWT header to fetch the relevant key for its file system. Okay, to solve the lab, we need to forge the JWT that gives you access to the admin panel, and we need to delete the Carlos account, and we have the credentials Wiener and the password is Peter. So I already open up the lab here. So now let's go. I'm going to enable the burp proxy on my browser and just go to my account. So here username is Wiener and the password is Peter. Don't save, and we logged in. Go back to the burp suite, go to the HTTP history, and all the highlighted request contains the JWT token. And if we go to my account request, we can see the cookie has the JWT. Now let's try if we can access admin panel or not. So as you can see, we need to be administrator if we want to access the admin. Now the thing is, we are going to solve this lab in few steps. So the first step is going to be generate the new symmetric key. Okay, then the next step is to modify the JWT. Third step is to sign the token, right? So that's it. So the first thing, it's not symmetric, it's symmetric. So now the first step is generate the new symmetric key. So first of all, we are going to send this admin request to the repeater, and let's go to the repeater and send the request again. And as you can see, 401 unauthorized means we are not authorized to access /admin. Now go to the JWT editor key. This key belongs to the previous lab, so I'm going to delete this. And now we need to generate the new symmetric key. Now the thing is, the question arises, how we will know that we need to generate the symmetric key or RSA key? So that you will know from here. This is the genuine JWT token which we are allotted. So click on the header part and go to the inspector, and here you can see the algorithm. So in the algorithm, it is already mentioned that the algorithm is HMAC SHA-256, which is a symmetric algorithm. So that's how we know that we need to generate a symmetric key or a RSA key. Okay, let's go and generate the new symmetric key and generate the key. Now the thing is, here I need to change this value AA equal, and this is the base 64 encoded form of the null byte. So I'm going to just click OK, and the key is generated. Now I show you what is AA equal. So decode as base 64, and as you can see, this is null byte. Fine. So this is the base 64 encoded form of null byte. Now the next thing is, we generated the key. Go back here. The next step is to modify the JWT. Come here and select the extension JWT. And here what we need to mention is the value of KID, that should be the path to the file. So if you don't know what this is, you can go back to the directory traversal playlist where we cover the whole module, and here we are going to just give the path, which is dev/null, right? And here the subject we need to choose is administrator. Fine. And we just need to sign the token. So just click sign and sign it with the newly generated key which we generated, and as you can see, the algorithm is HS256. Click OK and just verify the token. So as you can see, JWS verified OK. Now we just need to send this request, and as you can see, 200 OK. That means we are able to access the admin panel here. So show request in the browser, copy that, come here, make sure you enable the burp proxy and just paste the URL which you copied, and here you go. So admin panel is there and we have two users, Carlos and Wiener. So we need to delete the Carlos account. So here we have the link to delete the Carlos user. Copy that link, go to raw and just paste instead of admin delete, and the parameter is username is equal to Carlos, and just send the request. And 302 found, it redirecting us to /admin 200. Okay, and congratulations, you solved the lab and user deleted successfully. So right click, show response in the browser, copy, go back, and instead of that just paste the URL, hit enter, and congratulations, we solved the lab and the user deleted successfully, and now we have only Wiener user, means the Carlos user is deleted. So that's it. If you have any query, please put your query in the comment section. See you in the next video. Bye.